So let's move back to idle, of course, and see how easy it was to complete the solution to our last activity. The tough part wasn't really the code. The tough part was getting this thing to work in your IDE or computer of choice. And looking at our other challenge of spelunking around the application will allow us to use our classic dir commands and help commands and other commands to take a look at the objects that we have in our system. In this case, we have things like the Klingon to be expected. We have our destinations and sub-destinations, and we have a sparse map. Wow, look at that. There's our game all set into the environment and accessible now by using dir up to and including running help on any of our objects, noting that we are indeed case sensitive. We try, for example, to say help on a lowercase game. We're going to get our exceptions, of course, because the game's not defined. And Python's help system has been updated enough to allow us to take a look at the real meaning. In this case, we wanted to use the uppercase version to take a look at the documentation we've provided. And Python is enhanced a little bit on the main game class. The member functions, of course, are wonderful enough to be getting on with, and the documentation, which has to be read, has better and more modern ways to peruse it, and we'll be talking about those options, at least one of the ones I like, at the end of this video. Now, you even notice that we have our static identifiers of ST console, ST default, and ST network, all there documented and pulled right from the code by the Python help subsystem. Taking a look at the game map gives us a lot more squeeze lines, in this case 139, but the game map is what we probably want to be hacking at some point in time, at least so as to decouple it from the gameplay and put that map over on the server, so of course many people can have access to the game map. We have many different plotting opportunities on the game map, which is kind of interesting because we have those abilities to plot things on the screen, which are going to have to go over to the GUI from the TUI, or I suppose our GUI TUI, since we're going to be using a canvas from the TK Inter application, but to our solution to the challenge of changing our display. All we had to do, of course, was to open up our console, take a look at what's going on in there with the idle editor, to notice that although we have a test case, we're going to run the same problem. Even though everything looks fine, it's taken directly from our previous example, things are going to work even when we do our requirement of hacking our display for the test case. And the reason why it's not going to work, of course, you could probably guess, is yes, of course, we didn't import our sys as well as allow for our PyTrek module to be found by the interpreter. Making the update, then all we have to do is exactly the same thing so that we can import things from the PyTrek module, of course, by appending our parent directory. Next time we run our program, of course, all is well. Then we can see our little hack, our solution, by having successfully appended a string, or hacked a string, if you will, in front of our console program. That, of course, being another wonderful reason why we should have many unit tests, or small hackable tests, that we can run by using our dunder name equals dunder main gatekeeper in every and any Python file. So when I was on LinkedIn the other day, I had a friend of mine tell me about a wonderful product they have that's called Product Map. And by the miracle of using AI, Product Map will allow us to take a look at source code bases and have the AI summarize what the AI sees going on there. And in this case, you can take a look at the PyTrek from the Product Map AI to see that, of course, we're going to start off by running our space simulation game. So smart enough to determine that. To implement our error handling, we didn't talk about that. To control and manage ships, well, we lightly talked about that. or manage the game world before we run our core game logic. Not a bad shot for a pretty decent AI, including the code snippets, as we'll be seeing, that allow the AI to come to their conclusion. Running the game, of course, we see that we have to process movement, control game execution, and handle user interactions. Of course, that while forever loop, all running under the core game logic. Talking about user interactions, of course, we have to process user commands, those little tokens we talked about in C, as well as display the mission objectives, the main screen of PyTrek. Wonderful, wonderful insight, as well as recommending the code that we can look for and what that code does according to the AI. And these are not my help strings. This is the AI take a guess and quite accurately describing not only what it sees going on, but more importantly, including the precise code snippet that we should be looking for in our code, along with the line numbers in those files as well. Wonderful, wonderful insight as we take a look at our nav command, the subcommand, as well as all the other commands that we can use that more importantly will invite us to take a look at other code that is in our programs, allowing us to cut to the chase, if you would, for every subsystem that we see displayed on our mission objectives folder, up to and including managing our default command whenever things aren't going or aren't detected in the way that we see. Very hackable, very easy to understand, and wonderful product map product, allowing a new generation of software to do similar things for much more complicated and convoluted code bases like Doom, a classic game, or even something modern and well-written, as we see with NASA's core framework for managing their functions as well as services, which refreshingly includes the ability to do self-diagnostics, which you can imagine we've seen wonderfully done in space vehicles, as well as manage its own testing, simulation, and model validations, even execute test cases on its own code base. Very sophisticated and very much part of the diagnostic administrator that we'll be talking about later, so as to allow us to be not only decoupled and service multiple users, but also support an admin user or a self-diagnosing routine in our game as well. So I hope you feel free to take a look at Product Map and tell a friend, because if you're like me, whenever you drop right into a project, having the ability to quickly have an artificial intelligence take a look at your code base or anybody's code base and offer some wonderful code snippets as well as insights into what's going on in that code base can save you a couple of days. And of course, time is money, so it might be worth your investment to get a subscription to Product Map. So our ready stage is really all about taking the time to explore what we have going around us, and part of that exploration process, I think, would be to find a way to list all the classes that we have in our package, sort those class names by names, and ask yourself if they could be named any better. That's certainly something I do when I start refactoring, even when I've written something for myself. And I'm surprised how often, simply by looking at my own code, I come up with a better way to do things, certainly if I'm using AI or simply refactoring somebody else's code from a public domain project. And as we list those classes, let's list them by types. In other words, what are they actually named in addition to what abstractions are they using, or what other types are we inheriting from in those classes? And ask ourselves, is this the best architecture given the names? Because the most important part, I think, of refactoring is to making sure that our objects match our problem domain. In other words, if we're going to call it a calculator, is it a distance calculator? Is it a ship calculator? Is it a star-based calculator? Is it a Klingon calculator? Is it an enterprise calculator? All of these things are something you must spend some time thinking about if we're going to want to spend less time thinking about them when we pick up our codes. Once again, someone told me when I first started programming decades ago that any code that we haven't taken a look at in 3 months is just as good as having been written by somebody else. So the people we're refactoring for, it could be the general public, But I do refactoring for my own sanity, knowing that the older I get, the lesser I'm going to remember, and naming my classes appropriately is a do unto me as I would do unto thee kind of activity that pays huge dividends in the future. So finally, the last thing we should probably do is consider adding new ships or ship services or game technology, for example, VR or maybe graphical icons or maybe multiple windows. And like when we're brainstorming in any agile process, there's no holds barred in what we can be thinking about. And the more bizarre, sometimes the better, because that will give our games or our projects a competitive advantage to boldly code what few people have even bothered to consider synergizing with. Once again, collecting everything we have in whatever way you feel fit, whether it's a text document or a collaboration system or simply notes to self. Your next mission is to complete the ready cycle by exhaustively listing everything we think we can do moving forward, examining the past, looking at the present, so that we can adequately chart our course back to the future. Happy hacking, and I'm looking forward to seeing you next time in our hack-a-game, Hack Attack for PyTrek.